All right, so we will be working on completing the square. Completing the square allows you to write something that is, well, kind of like this, a general quadratic, and then rewrite it as a perfect square. So a binomial that is squared. Um, Really important. It helps us find the locations of centers of conic sections, of vertices, of parabolas. Generally, a good generally a technique that makes solving equations easier lots of times. There's sometimes when the completing the square is not appropriate for solving equations, and there's other techniques that are, but it comes up a lot. So completing the square, generally speaking, means writing something like this. So x squared minus 6x, expressing this as a perfect square. What do you need to add? What do you need to complete that square? So I've got an example. We did this earlier in the year. We did it last year for expanding a binomial. We used this multiplying using the box technique. So x minus 3 times x minus 3, and we get x squared. And we get negative 3x here, negative 3x here. And then what does it need down here? Well, that comes from this negative 3 times this negative 3, basically negative 3 squared. So this needs, this over here, in order to be a perfect square, it needs 9 added to it. Now this is exactly x minus 3 squared. And I can substitute wherever I see x squared minus 6x plus 9, I can write x minus 3 squared in its place, which is really powerful, actually. Okay, so one of the things that you'll notice is if it is a perfect square, this number and this number will always be the same. If they weren't the same, then you could think of that as part of the length of one of the sides of that box, of that rectangle. Well, then you would have different lengths and it wouldn't be a square. If it's a square, if it's a perfect square, this length will equal this length. So we would expect this and this to have the same length, to have the same expressions there. Okay, so because we want it to be square, we know this number here has to equal this number here. So I'm going to take half of my x's. So I had 6 negative x's. I put half of them here and half of them here. It's always going to be half of them. Okay, so let's try to complete this square. I have negative 10x, so I want to take half of those 10 negative x's, put half of them here, and put half of them here. What's half of 10 negative x's? 5 negative x's. So 5 negative x's go here, and 5 negative x's go here. So with that being done, now I know this has to be x minus 5 on top. This has to be x minus 5 along the bottom. They are going to be a perfect square. This perfect square is going to be x minus 5 squared. Where did that minus 5 come from? It always comes from half of this linear term. We call it the linear term to the first power. Half of this is what gives us this. If it were plus 10x, then each of these would have been plus 5x, and I would have plus 5 here. Oh, because these would have had to be plus 5. Okay, but it wasn't. Let me put all those back. Okay. So what is it missing then? What is this missing to make it exactly equal to x minus 5 squared? Well, it's missing whatever's in this bottom box. Whatever's in this bottom box always comes from this number here times this number here. So in this case, it's 25. But where did this number come from? This number was half of my coefficient here. So I actually don't have to reproduce this box. I could actually do this without it, kind of noticing that pattern. Now, if I were to add 25 to this expression, now this is exactly equal to x minus 5 squared. So now I can substitute them. I can put x minus 5 squared in its place. Really powerful. And the huge power comes from, I know if I've got an equation of a circle where these are perfect squares, I know where the center is. The center is at 3, -2. And I know what the radius is. The radius is 5 because it's the square root of this number over here. That's really powerful. So if somebody gives me something that looks like this, yuck, and they say, what's the center and the radius? I'm like, oh, shoot, it's a lot of work here. So what you need to do is you need to use this completing the square process. And I'll show you this process here. So the first step is to gather my x's together. So I'm going to put them together, plus 8x. And I'll be completing 2 squares here. I'm going to gather my y's together. My y squared plus 2y. So y squared plus 2y. And then anything that doesn't have a variable, like my -8 here, I'm going to get it to the other side. So in this case, I will add 8 to both sides. So then I have equals 8. So far, so good. Okay. Now, the box technique would say, and I'll do the box technique here, and then I'll show you how I would do it without. Say, put the x squareds here, take half of my 8x's, put half of them here, and half of them here. So then this has to be x plus 4, because this is going to be x. And so this has to be plus 4, because how do I make a 4x if one of the factors is x, but by 4? So this has to be plus 4. What's it missing that's making it a perfect square? The contents of this box down here are going to come from 4 times 4, 16. This will always be a perfect square. So if I add 16 to this, I can replace x squared plus 8x plus 16 to something that's way more useful when I'm dealing with circles. This is x plus 4 times x plus 4. X plus 4 squared. Okay, but what I had wasn't, this is what I had initially. I had to add 16 to make it equal this. So I added 16 over here. I have to add 16 over here to this side of the equation also. Okay, so now I can replace x squared plus 8x plus 16 with x plus 4 squared. I know the x coordinate now, x plus 4 squared. I know x equals -4 is the x coordinate of the center, right? What do I need to plug in to make 0? -4. So -4 is my x coordinate. Let's complete this square. Okay, so let's try to do it without the box. So I'm going to have something squared. So y. So where did this plus 4 come from? It came from half of 8. So in this case, over here with my y's, I have plus 2y, so I'm going to take half of that, plus 1. Okay, now where did this 16 come from? It came from this number squared, 4 squared. So here I have 1, so I need to add 1 squared to make this a perfect square. Now this is equal to y plus 1 squared. So my equation, I now know where the center is. I know the y coordinate is y equals -1. And I added 1 here. I have to add 1 here. So now what's 8 plus 16 plus 9? It happens to be 25. So I know the radius too. The radius is the square root of this. Square root of 25 happens to be a nice number. The radius is 5. Okay. How about this? The center of a circle is located at 3, -4. The radius is 6 units. What is the equation of the circle in general form? So this one, I could do it a couple of ways. I could just write out, if I know the center is at 3, -4, then I know the equation is going to be x minus 3 squared plus y plus 4 squared equals, and the radius is 6. So then I know this is going to be 36. That's what the equation should be. So now, which of these is equivalent to it? So here I've actually got to multiply out. Again, using the box technique, x minus 3, x minus 3, x squared. I have a minus 3x, minus 3x, and I have plus 9. This will always be positive also, thing to remember there. So this is x squared minus 6x plus 9. I'm going to stop right now, and I can rule out these two because they both have positive 6x. So I can rule that out. This has a plus 9, and we had, let's see, plus 36. So I don't think I'm quite ready to decide if it's this one or this one. But they both have positive 8y. So that's not this. The number that's the difference is that constant that's added. So is it plus 19 or is it minus 11? Okay, so I'm going to do this one. I'm going to expand this without the box. Y squared plus 8y. So 4 times y times 2. 8y plus 16 equals 36. Okay, I'm going to add these two together. 16 plus 9 gives me 25. And I'm going to minus 36. Minus 36 from both sides. So minus 36. And right now I'm thinking this is going to be the correct answer. Okay. Or you could have worked backwards. I could just complete the square here. X squared minus 6x. And I have y squared plus 8y. The downside here is I've got to do this potentially 4 times. I don't want to do this 4 times. So this is going to be x minus 3 squared. That's what it's going to turn out to be, right? Half of this. What do I need to add? Plus 9. So here I've got 36 over here. And this is, oh, actually, I don't have anything over here. So we've got y plus 4 squared, right? Half of 8 is 4. It needs a 16. Okay. So then I have 25 over here that I added. And then we know the radius is 36. I'm looking at my timer. My timer is really low. All right. So there's a lot of ways to approach these. Completing the square is a great practice for our multiplying out and foiling out that we did earlier this year as well as last year. All right.